Hello, good day. Today I will show you how you can use RCC11 element design spreadsheet program to design T-beams. So to design T-beams, just go to the tab here, T-beam. After rectangular beam, we have T-beam. Now you click on it. This program designs to BS8110. So you can see the title is for design of T-beams and L-beam. We'll enter data in blue cells only. These are where you can input data. You can change your data. Now let's explain the input section. Now in the input section, we have the location where you input the name. We have the parameters, the design parameters of the beam. We have M, which stands for moment, design moment. We have B, which stands for redistribution factor. We have span, which stands for the span of the beam. We have H, which is the depth, overall depth of the beam. We have BW, which is the width of the beam, the underside width of the beam. We have BF, which is the flange width of the beam at the top. We have HF, which is the thickness of the slab section. That is also part of the overall depth of the beam. Then here you enter your reinforcement. In this case, it is 25 mm. And then for top steel, compression steel, we can put 12. Now we have the FCU, which is the strength of concrete. We have FY, which is strength of steel. Factor of safety for concrete, which is 1.5, and factor of safety for steel, which is 1.05. Now we look at the compression cover, tensions cover, side cover. All these values can change based on your design situation. Over here, we can select the type of beam based on whether it's a simply supported, end span, interior span, and support. So contact your BSS 8110 code for more insight into all this. Then we have choose section type. So it can either help you design a T-beam or an L-beam. You can see if we change all these, it has an effect on the calculation result as well. So let's leave it at what it was before, simply supported and T-beam. So your moment is based on the design load on the beam. Prior to using this RCC11 spreadsheet program for T-beam or L-beam design, you would have calculated your design moment based on the design load acting on the beam. Let's move to the output section. You can see the output section. The results are perfectly arranged. These D represent effective depth. The effective depth is calculated by deducting the cover to reinforcement and half diameter of the steel from overall H. Here we have K, that is moment capacity, which is 0.156. The calculated K is 0.029. So since this calculated K is less than this K, compression reinforcement isn't required. But nominal steel for compression needs to be provided. And that's why we have the top steel, two numbers, 12 here. This one is also subject to change. Now we have X, which is neutral axis. We have the calculated area of tension steel. You can see it in this case 1761 millimeters squared. It now provides, based on this, provide for T25 bottom. Based on the area of T calculated and the area of T provided, we can modify and check for deflection. So you can see the calculation for check in for deflection. Now when we move over here, this place tells us, it looks at other things that validate the design here. It gives you insight. For instance, here it shows that the pressing program, when you look at maximum S, this maximum means maximum spacing. It shows that the program is checking for maximum spacing of the reinforcement bar. So if they are too close together, it's going to give an error. But in this case, there is no error. After you have checked your design, you have changed values here and all that, you can now print your work. Just go to File and click on Print. Here you can print the results of this particular beam design. Okay, you can save it to PDF and save it as a file in any location on your computer. So this is the general way you can use this program to design T-beam and L beams. Now, to better understand your spreadsheet program, if you feel it's so overwhelming, you can always ask AI to help you to understand all this. AI is going to tell you, each and every parameter, including what is here, so you can better understand the spreadsheet program. And now I've gone ahead to visualize what is shown here and let AI explain to me. So for instance, if you are confused of what H is, what BW is, or what BF is, you can just take a picture or snap a screenshot just take a screenshot, post it on the AI like Gemini AI, and then say, explain this in a diagram. So I have done that. So let me open it. So this picture was created by AI to explain what we have here in this spreadsheet program. And as I said earlier, what you just need to do is take a screenshot of maybe the input or the output section, upload it to Gemini AI, and then you now type, explain this in a diagram, and it can bring you something like this. You can also experiment with other prompts that can help you better explain each and every parameter in this spreadsheet program. So in this case now, you see that AI has drawn the section of the T-beam. So based on the parameters we have here, let me zoom. Now you can see all the parameters here that is written. You have to cross-check it. This is just for you to understand. If you use AI to produce this, you must check everything, that everything is correct. And anyone that is not correct, you can always tell AI to help you correct it, or you edit it on your own. Okay, so now let's look at this section. This is the T-beam. This is what it looks like. And so if you're unsure, you see BW. BW is the width of the beam, the underside width of the beam. And because it's a T-beam, it has a flange width. This flange width should be BF, but it's incorrectly labeled as BW. You can see where you need to be careful when you use AI to do things. So this BW, this is what is here. This should be here. BF is what should be labeled here. It correctly gets this one as HF. This is the thickness, actually the thickness of the slab, but it is part of the overall height of the beam, because these beams are usually designed to support slab. So this part HF is the thickness of the slab part of the beam. So you can see it here. Okay, it tells us what the span is. So if you don't have any idea of what the span looks like, you can see it. That's the length of the beam, the span. So it goes on to show us how the calculation went about. Now, there's one thing I want you to look at, is how the AI gives you insight into calculating BF. So you can see this BF here is calculated based on the BS811 code, which is BW. This BW here, which in this case is 300 plus 0.2 times span. So in this case, it's 1900 millimeters, which corresponds with what we have in the spreadsheet programs. But this is very helpful to you to quickly visualize or understand up to 80 or 90% of what this spreadsheet is all about. We have basically come to the end of this tutorial. The download link to RCC11 element design and other spreadsheet program is included in the video's description. Try to become a member of this channel. You will have access to more extensive videos on reinforced concrete design. And if you want me to teach on a specific part of reinforced concrete design, you will let me know, and then I'll produce the video for you. Also, every work materials that is used in the tutorial will be available in the video's description. So when you have the opportunity, support this channel by becoming a member of the channel. Thanks for watching. Like and subscribe for more reinforced concrete design videos.